Hello everyone, myself Sakshi Gajanan Raut from section A, roll number 37. Today I will try to explain one of the topic from engineering physics, which is motion of electron in transverse electric field. So let's start. Consider two plates placed parallel to each other. This is plate A and this is plate B. Plate A is positively charged and plate B is negatively charged. Due to these charges, an electric field will generate in vertically downward direction like this. Here one electron gun is present through which an electron is emitted. When electron enters in this electric field, it will experience an electric force and hence it gets attracted towards this positive plate as electron has negative charge, and hence path of electron bends towards this positive plate, and as electron comes out of this electric field, it will move in straight line, as here any force does not exist. Now let's understand motion of electron in x direction. In x direction, initial velocity of electron is ux. Here motion of electron initially is only in x direction, and further as electron moves forward it will experience force only in y direction. So motion of electron in x direction is be taken as ux, and acceleration in x direction will be 0, as here motion of electron is only in y direction. So further velocity of electron in x direction will be constant. Now let's understand motion of electron in y direction. In y direction, initially electron moves only in x direction, so initial velocity in y direction will be 0, and as force is acting in y direction, it has acceleration in y direction, which is given by ay. Now let x be the displacement in x direction, x be the displacement in x direction, which we can calculate by the kinematic equation s equals to ut plus half et square. In our case, as x is the displacement, so we can write x equals to uxt plus half ax t square, where ux is the initial velocity of electron and ax is the acceleration of electron in x direction. So as we discuss, acceleration in x direction is 0, so this whole term will be 0, and we get x equals to ux t, which is motion of electron in x direction. So for time we can write t equals to x by ux. Equation number 1. Now motion of electron in y direction, so let y be the displacement in y direction, which is given by y equals to uyt plus half ayt square. As we know that initial velocity in y direction is 0, so this term will be 0, and we get y equals to half ayt square, which is our equation number 2. When electron enter in the transverse electric field, it will experience an electric force, which is given by Fe equals to small e into capital E, where small e is the charge on electron and capital E is the electric field intensity of an electron. According to Newton's second law, we can write force equals to mass into acceleration in y direction. Here we take acceleration in y direction, as we know that motion of electron takes place only in y direction. Let's call it as equation number 4, and this is our equation number 3. So here on comparing this equation number 3 and 4, we can write small e into capital E equals to mass into acceleration in y direction. So for acceleration we can write Ay equals to small e into capital E divided by mass. Let this is our equation number 5. We have equation number 1 for time and equation number 5 for acceleration in y direction. So by using these two equation number 1 and 5, we can write equation number 2, which is y equals to half ay t square. Here instead of ay we can write small e into capital E by m, and for t we can write x upon ux whole square, which is 1 by 2 x square by ux square, which is y equals to k x square, where k equals to 1 by 2 small e into capital E by m ux square. From this equation we can say that electron takes parabolic path in the region of transverse electric field. This is all about motion of electron in transverse electric field. Thank you.